So in the previous video we saw how to approach towards the root of an equation using Newton-Raphson method. But now we are going to derive the formula for Newton-Raphson method. First of all, we have an equation f of x equal to 0 for which we have to find the root. Some number that we plug in the place of x and it gives us 0. So that would be the root of this equation. All we know that is f of x is continuous on an interval AB such that f of a is negative and f of b is positive. Let's draw a graph based on this information. Let's roughly mark this point A and this point B. Now f of a is negative and f of b is positive. So f of a is negative, we are marking it here, and f of b is positive, we are marking it here. Now we also know that the graph of the function f of x is continuous in between a and b. So we will join this point with this point. Now for Newton-Raphson method, we need one point to start. Either A is going to be our starting point or B is going to be our starting point. So we are taking B as our starting point and denoting it as x0. One thing that you should know that this graph is cutting the x-axis at this point. So this point is the root that we are trying to approach by using the Newton-Raphson method. So we have the starting point x0. To start, what you do is go up against x0. So the coordinates of this point are x0, f of x0. Draw a tangent line at point x0, f of x0. So it's like this. This point is x0, f of x0, and we are drawing a tangent line. So tangent line is extended both sides. So draw a tangent line at this point. And this tangent line cuts the x-axis at a point. Let's name this point x1. At this point, x1 is the x-coordinate, and since on x-axis all y's are 0, so y-coordinate is 0. So this tangent line is cutting the x-axis at point x10. Now you will recall from the previous video that this tangent line has the slope, and its slope will be denoted as f dash. Since we drew this tangent line at point x0, so the slope of this tangent line is f dash at point x0. We started with the point x0 and we got a point x1. Know that x1 is not the root. The root is this. We have to get towards this root. But for now, we will try to find the point x1, which is not the initial point. Initial point is x0. Let's take this tangent line out of the picture. This tangent line is this line. This line is passing through or touching the curve at this point, and the slope of this tangent line is f dash x0. Let's write equation of this tangent line. And again, from the previous video, you will recall that the equation of the tangent line can be written using a point through which the line is passing. Here the point is x naught, f of x naught, and this line has the slope which is f dash x naught. So the equation of the tangent line is y minus the y coordinate of the point through which the line is passing, slope which is f dash x naught, x minus x coordinate of the point through which the line is passing. So we have written an equation of this tangent line. Now let's look at this tangent line that we have taken out of the picture. This line is passing through the point x naught, f of x naught, and a point x1, 0 is also lying on this line. We have already written an equation of the tangent line. Now the point x1, 0 is lying on this line. We have to make this point lie on this line. But before we do that, let's have a look at this straight line, y equal to 2x plus 3. If I say that the point 0, 3 is lying on this line, you will make this point lie on this line. How would you do that? This goes in the place of x and this goes in the place of y. So y is 3, 2, 0 plus 3. So this is how you make a point lie on the line. Now let's get back here. We have to make this point x1, 0 lie on this line. This goes in the place of x and this goes in the place of y. Make it lie on this line. So in the place of y we have 0 minus f of x 0, f dash x 0. We are not touching anything other than x, y. Just like in this, when we made a point 0, 3 lie on this line, we kept 2 as it is, we kept 3 as it is, we kept plus as it is. The same way, we are changing y as 0 and x as x1. And we are keeping everything else same. Now we simplify this to find x1. We do cross multiplication here. Now I keep x1 on the side and take x0 on the other side with the change of the sign. So this is how we get the point x1. Now let's go back to the graph. After we get the point x1, we go up on the graph against x1 and draw another tangent line that cuts x-axis at a point, call it x2. Again, go up on the graph against x2, draw another tangent line at that point on the graph, and this time this tangent line cuts through the root. So the root is x3. So this is how we gradually approach towards the root starting from x0. We have the formula for x1. The same way we could find the formula for x2, which would be, we are just looking at the pattern of x1. x1 minus f of x1 over f dash x1. The same way we can write x3 looking at the pattern for x1 and x2, which would be x2 minus f of x2 over f dash x2. So we can now write a general formula for Newton-Raphson method. Xn plus 1 would be equal to xn minus f of xn over f dash xn, and here n is 0, 1, 2, 3. So using this Newton-Raphson general formula, we will find different x's, x1, x2, x3, and so on, and one of these x's will be the root of an equation f of x equal to 0. In the next video, we shall try a question where we have to find the root of an equation by using this Newton-Raphson method.